Welcome back to Orders of Magnitude, where the hidden math of everyday things turns out to be stranger than fiction. 3 doors. Behind one of them, a brand new car. Behind the other 2, goats. You pick a door, say, door 1. But before it opens, the host, who knows where the car is, does something strange. He opens a different door, door 3, revealing a goat. 2 doors are left, your door 1 and door 2. And now he asks, do you want to switch? Your gut says it can't matter. 2 doors, 1 car. 50-50, right? Switch or stay, who cares? Your gut is about to be very, very wrong. Here's the truth that has started arguments for decades. If you stay, you win the car 1/3 of the time. If you switch, you win 2/3 of the time. Switching doesn't just help, it doubles your odds. When this answer was published in a magazine in 1990, it triggered 10,000 letters of protest. Nearly 1,000 of them from people with PhDs, all insisting it was nonsense. Mathematics professors wrote in to say a woman had embarrassed herself. She hadn't. She was right. And by the end of this video, so will your gut be. To see why, we have to notice the thing everyone's gut quietly ignores: the host. He is not opening a random door. He knows where the car is, and he will never open the car, and he will never open your door. He is forced to show you a goat every single time. That single constraint is doing all the work. The host's choice isn't luck, it's information. He's quietly telling you something about the door he didn't open. Let's just check every possibility. Say the car is behind door 1, and you make your first pick. Case 1. You pick door 1, the car. The host opens either goat. If you stay, you win. If you switch, you lose. Case 2. You pick door 2, a goat. The host is forced to open door 3, the other goat. Switch to door 1. You win. Case 3. You pick door 3, a goat. The host must open door 2. Switch to door 1. You win again. Look at the scoreboard. Staying wins in 1 of 3 cases. Switching wins in 2. Your first pick is probably a goat, 2 times out of 3. And when it's a goat, switching always lands the car. It's not 50-50. It never was. If that still feels like a trick, here's the version that makes it obvious. Forget 3 doors. Imagine 100. You pick 1 door. The odds the car is behind your door? 1 in 100. Almost certainly, it's somewhere in the other 99. Now the host, who knows where the car is, opens 98 doors, every one a goat, and leaves just 1 other door closed. So now, your original 1 in 100 guess, or the single door the host went out of his way to leave standing. Suddenly, it's obvious. You switch. That lone door carries the 99% your guess didn't. The 3-door game is the exact same trick, just harder to see. But you don't have to trust the logic. We can just play. Here are 1,000 games on autopilot. A player who always stays, and a player who always switches. Watch the numbers settle. Stay, around 330 wins. Switch, around 667. Not a coincidence, not a rounding error. 1/3 versus 2/3, exactly as predicted. Run it 1,000,000 times and it only gets sharper. The math isn't an opinion, so what actually happened here? When you first picked, your door had a 1/3 chance, and the other 2 shared 2/3. The host opening a goat didn't touch your door. Your odds were locked in at 1/3 the moment you chose. But the 2/3 the other doors held? It didn't vanish. It collapsed onto the 1 door he left closed. This is the heart of it, and it's a habit of thought worth stealing. New information should change your mind. The host's action was a clue, and updating on clues like this even has a name: Bayesian reasoning, the math of revising what you believe when the world hands you evidence. And this isn't just a game show curiosity. The same trap shows up wherever a gut feeling meets new evidence. A medical test comes back positive. Your gut screams the worst, but the real odds depend on how rare the disease is and how the test behaves. Exactly the kind of updating the host forced on us. Detectives, scientists, investors, All of them live or die by whether they can update instead of clinging to a first guess. The Monty Hall problem is a 1-minute lesson in the most useful skill in probability. When the facts change, switch. Which brings us back to those 10,000 angry letters. The columnist who gave the right answer was Marilyn Vos Savant, and the professors who mocked her quietly wrote back to apologize once they ran the simulation themselves. Even Paul Erdos, one of the most prolific mathematicians who ever lived, refused to believe it, until someone showed him the games played out, one by one. If it can fool him, your gut is in excellent company. So, 3 doors, 1 host who can't show you the car, and a 1/3 guess that's almost always wrong. Switching doubles your odds, not because the door changed, but because you learned something. The next time the world opens a door you weren't expecting, don't cling to your first guess. Update, switch. If this rewired your intuition even a little, hit like and subscribe, and we'll keep finding the hidden math in everything. See you in the next one.